Hello, I'm Æyers, and this week my goal was to make a letter cube with my 3D printer. Let me tell you, it didn't happen. I both overestimated how much time I would be able to spend on my project this week, and underestimated how much work there is to be done to get my 3D printer running. I still managed to create the 3D model of my letter cube, as well as support it and get it ready for 3D printing. There's still a lot of work to be done to get my 3D printer working. First, I have to do the first time setup. So I need to connect the physical pieces together. I need to level the printing platform. I need to do several test prints just to make sure I've got all the settings dialed in. And then at that point, I'd be ready to 3D print my letter cube. Printing the letter cube itself is its own process. I have to get the file onto the 3D printer. I have to fill the printer with resin. I need to run it, which will take a long time. And then I need to clean off all the supports. I need to wash off all the extra resin off of the 3D print. And then I'll need to cure it with my UV light curing station. And then, and only then, will I have my 3D printed letter cube. It'll take a while. We'll get back to it. The first thing we need to do is actually create the cube in a 3D modeling software. So this is Blender. On each side of the cube, we have my initials A, N, and E. So if we look at it this way, you can see the A. If you look at it this way, you can kind of see the N. This one was tricky. We'll go into that in a little bit. So that's the N. And then on this side is the E, easily seen. So the trick is that as long as your letters have sides that are completely full, it'll be easy to put them together in a way that works. So a normal N would have this whole area cut out instead of having this little section here. But you can see that if we were to cut that out, instead of little notches here, we would have this whole section be gone. And with this whole section gone, at least for this bottom part, with this whole section gone, this piece wouldn't stay on anymore because it wouldn't be attached to anything. And so we've got to have at least some portion of the whole side be connected, or it won't work. The A and the E are pretty straightforward, but making the N I had to get clever because we needed to have this section here. So I found out recently that you can just Google like N logo, and like a million pictures of stylized N's will come up. And so it really kind of boiled down to two options. One option was, instead of having the N be the part of the block and then cut out where the N isn't, we could have done the reverse and have a negative space N, where the whole block is solid except for a little N zigzag. But that looks really weird when the other letters aren't like that. Like, I could do that for all three letters and it would look fine, but I like this way better. The other option is just having, like I've done here, the whole outline be filled in, and then just trying to cut out something to make it look like an N. And so I think what really makes the difference for this is when I was drawing it by myself before I started looking at the logos, is I had, instead of this diagonal, I had it straight down. And it looked really clunky and weird. Once I got looking at the logos, this angle being the same as this angle really made it look a lot better. Now that we have the cube, we're going to save it and export it, and we'll bring it up in the next software. So this is Mesh Mixer, and so what we're doing here is we're orienting it. So that's the first thing you'll notice, is that the cube is actually on its point instead of flat like it was before. And this software does not focus on visuals at all, so that's why it looks terrible like this. But this is actually fine. This is how we expect it to do. So we just need to hit analysis, and there's a couple things we can do here. If we hit orientation, and then we can click on the different letters, and it'll rotate it different ways. This orientation, the software thinks this orientation is best, and I also think that, because if you'll kind of look at it, so the reason we like this orientation so much is that as our 3D printer builds layers from this bottom point up, there's not going to be too many points that aren't supported. When we flip it upside down, the opposite of the orientation we're going to go for, you can see that as it starts building up like this, each of these sections is going to be entirely unsupported. And so he'll have to put in a ton of supports in order to make sure that this section prints, and that this section prints, and that this section prints. But if we go with this orientation, all of those are pointing up. And so this whole section can just print nicely without almost any supports at all, and it'll print just fine. We will still need some supports. You can kind of see that this point here is coming down, so that'll need a support, as well as some of the edges of these circles. We'll need some supports here, even if it's not necessarily coming down. The printer will also struggle to print kind of horizontally. So this is the orientation we'll be in. One last thing is that something went wrong with our scale. And so as I'm zooming all the way out, theoretically this gray area is the size of our 3D printer. And so this thing is tiny. So what's happened is in Blender we designed it with centimeter units, and the default for this program is millimeters. So when we change this to centimeters, it'll convert it into a much more reasonably sized cube. That is going to be much more printable. The next step is to export it from this software and put it into Linchi, which is a software that can add supports and can slice it. So this is Linchi. It has an at-scale feature you can turn on. And I noticed that I didn't actually want centimeters, I wanted inches. So I have fixed that now. But basically, what we do in Linchi is we add supports. It does have a Generate Automatic Supports button. I'll just slam that button real quick. Okay, so it puts on, first of all, a ton of supports. Second of all, sometimes it'll miss important areas. It looks like it's done a pretty good job this time, just because there's supports literally everywhere. So I've changed the settings so that the supports all go to the ground instead of going in between the 3D printed object and somewhere else in the project. So now they're all coming in from the side like this, rather than going in between this side of the circle and that side of the circle, because that'll be a nightmare to clean. We want to make sure that it has this tip supported, and it looks like it does pretty well. We want to make sure that it has a lot of the circle spots supported. So it has, you can see in here that we do have a support in here, but it's not touching the bottom like that. And we only really have one, so we might want to add another one in there somewhere. Then for this one, it's got one support in here, which we like, but we want to add in at least one more for sure. And those supports are coming in from a different direction, just for funs. I don't know why. And then it has a bunch of supports just kind of like going all over the sides, just to hold it up, because all the weight of the cube needs to be supported by all these supports. This is a good preview of what the 3D printer will print on each layer. So as I drag this up, you can see the different things it'll print. And so just at the bottom here, these are all the bases for the supports. And then for a little bit, it's just supports. And then you can see this triangle start to grow in the center, and that is the actual part. And then as we continue to go up, the different parts of it that have been cut out show up. So you can kind of see an A and an E, and then the N kind of show up. And then you go all the way up to the top, and that's it. That's just the other point of the cube. So it'll take in between 5 and 30 seconds to print each of these layers, and there are a lot of layers, over 1,000 layers. But That's what makes it up. And then afterwards, after it prints, I'll have to snap off all of these supports. And, oh, this is good. This is a good view of showing how the 3D printer will print this piece layer by layer. So as I drag up this little circle, you can kind of see the piece start to form. And as it gets bigger, you can see the different cutouts. So if I go all the way up, you can kind of see that this side here is the E. And so as it grows, you can see the specific cutouts that the E makes as it goes. Pretty cool to look at. Now, I've told Linchi what 3D printer I have, and so it already has all the settings default in here. And so it has the slice thickness already in here, and then when I go to export, it already has everything I need, and this .pwmx file is the file type that my 3D printer recognizes. And that's all we need to do in here. There's one more program that will check over this sliced file and make sure that it is complete and that there's no errors in it, just to prevent some 3D printing mishaps later. Here we can see how much resin it'll probably take up and how long it'll take to print. 3D printing is not a fast process necessarily, but it's still cool. This week I lost my wooden ring, and so next week's project will be to make a new one. I had a couple woods to decide between, and I think I've decided on this purple heart wood. Thanks for watching. I hope you enjoyed, and see you next week.